I am going to go ahead and just demonstrate how we would do long division in 4th grade. So I figured that would be the easiest way to show you. Right here I have a problem, 839 divided by 7. This is a similar problem that you may see on Friday on our unit test. I can also write 839 divided by 7 like this. So this symbol here just represents the division symbol. The number here is called a dividend, and this is a divisor. So the goal is to try and see how many times we can put 839 into 7 groups, or another way to explain that is how many times 7 goes into 839. And then we're trying to figure out our quotient, which is right here on this model of division, and then would be right here, this position, the normal way that we see a division equation. So because I'm trying to figure out how many times 839 goes into 7 equal groups, I'm going to go ahead and put 7 equal groups on the side here. So I have 5, 7, and I'm going to want to put 839 divided up equally into these 7 groups. I could put a 1 in each of these 7 groups until I get 839, but I would probably be here all day. That's going to be really time consuming, and it's not the most efficient strategy. So instead, I'm going to try and figure out a number that I can put in each of these equal groups that will give me close to 839 without going over. I could put a 10 in each of these, but I know that 7 groups of 10, or 7 times 10 is 70, and that's still pretty far away from 839. So instead, I'll use an even bigger number that I'm familiar with, which is 100. So I'll go ahead and put 100 into each of these equal groups. What I just did is 7 groups of 100, or 7 times 100. 7 times 100 is a really familiar expression for me. I know how to work with this really easily. 7 times 100 is just 700. So I'm always looking for numbers to put in my equal groups that I'm familiar with and that are easy to work with. So I'll just take away 700 from 839, and I'm left with 139. So now I have to break up 139 into my equal groups. It's my new number that I have to work with. I could do 7 equal groups of 100 again, but that's going to get me to 700, and that's way too much. So I cannot do 100 into each group again. Instead, I'm going to try 10. So if I put 10 into each group, into my 7 equal groups, I just did 7 times 10, or 7 groups of 10. 7 groups of 10, or 7 times 10, is 70. So now I'm going to subtract that. Okay. 9 minus 0 is just 9. I'm running into an issue here, though. I cannot take 70 from 30, so I'll have to regroup 100. So that leaves me with no hundreds left, but I'll add that 100 to my 10. So instead of just 30, I now have 130. I'm just writing 13 on top here, though, because since this is in the tens place, I know that this 13 really represents 13 tens, or 130. So 13 minus 7, or 130 minus 70, is 60. So now I have 69 left. When I did 7 times 10, or put 10 into 7 groups, I got 70, which is way too much. I shouldn't say way too much, but it's too big. So I cannot put 10 into each of these anymore. I have to find a smaller number. But 69 is really close to 70, so I can find a number that's really close to 10 to add in each of these. So I'll go ahead and just do 9 into each of these equal groups. And if I know my 7's facts or my 9's facts, 7 times 9, so I did 7 groups of 9, 7 times 9 is 63. Then I'll subtract that, see how many I have remaining to divide, and I get 6. So I have to divide 6. But the problem I have is that I have 7 equal groups, so if I try to divide this 6 into 7 equal groups, I won't have enough. which means that this 6 is my remainder. To find my quotient, I'll add all my partial quotients together, or everything that I put into these equal groups. So I do 100 plus 10 plus 9, and I get 119. You'll also notice that this 119 is what is represented in each of these equal groups. So 119, 119, and so on. So my quotient is 119, but I have to remember that I also had a remainder. My remainder is 6, and that's my answer.